find Laplace transform and the ROC for all the functions whatever we do. The first one, delta of t. So Laplace transform of delta of t. So tell me, what is its value?
1.
1.
1, sir.
Yeah, this we already did in the classroom. Maybe I can recollect it once again. Integral minus infinity to infinite delta of t e power of minus st dt, and based on the property that delta of t into x of t is equal to delta of t into x of 0. So here delta of t into e power of minus st is written as delta of t into e power of 0. So this is how you get delta of t. So this one is rewritten minus infinite infinite delta of t into 1. So this is 1 representing the area under the impulse, which is 1. So therefore the Laplace transform of impulse is 1, and since this Laplace transform is a constant and it is not depending on s, that means that the ROC is entire s square. Okay. Second function, e power of minus a t u of t. This I am not going to do. Please tell me the answer.
1 by s plus a.
Yes, please.
What is the ROC?
Sigma greater than minus a.
Minus A.
Nice. Good. Now, can you tell me the answer for u of t now? Simply you can
1
substitute a
by
equal
s.
to, yeah, in the result, in the second result, you can simply go for substituting a equal to 0. Then what happens? E power of 0 becomes 1, you will get u of t. So that means 1 by s. Now, what will be the ROC in this case?
Sigma greater than 0.
Greater than 0.
Yes. Next, minus e power of minus at u of minus t. What is its Laplace transform?
1 by S minus A.
Mm-hmm.
Oh, 1 by S plus S. Yeah, 1 by S
Yeah.
plus A.
Yeah, ROC will be
Less than minus A.
sigma less than minus c. Great. Now, we'll go for a small extension for this. Minus u of minus t. What is the Laplace transform?
1 by s.
Yes. So Laplace transform here also 1 by s. But the difference here is
ROC is sigma less than 0.
sigma less than 0. Just substitute in place of a as 0 so that you will get the fifth answer. Okay. So let's remove one. Next, sixth one. Now, your skills of using the properties of Laplace transform comes into picture. T into e power of minus at into u of t. Can anyone suggest me what property of Laplace transform can I use? Check once. Is that differentiation in S domain?
Yes, sir.
So differentiation in S domain property. The statement is t into x of t will have the Laplace transform of minus d by ds of x of s. Clear? And the RBC is same R. Am I right?
Yes, sir.
Yes. So now this is in the form, the problem is in the form t into e power of minus at u of t. So this x of t is e power of minus at u of t. Now, if x of t is e power of minus at u of t, x of s is 1 by s plus a. So that's why here I am writing it as minus d by ds of 1 by s plus a. Please do this and tell me the answer. Please differentiate this and tell me the answer.
1 by s plus a whole square.
Yes, it is 1 by s plus a whole square. You can use u by v rule of differentiating this. So it will be 1 by s plus a whole square. And what is the ROC?
Same, sir. Same R.
Sigma greater than minus
Greater than minus a.
will be the ROC. Okay. So t into e power of minus a to u of t, Laplace transform is 1 by s plus a whole square, and the ROC is sigma greater than minus a. Now, this is for uh, maybe homework I can give you. So this is for your practice. T square into e power of minus e to u of t. Please try to find out. We will see in the next session. What is the Laplace transform of t square into e power of minus a t u of t? And you can even try for t power of n e power of minus a t u of t. You can give an answer in a generalized form. Try for t square. Try for t cube also, because until unless you go for t cube product, you can't generalize it. Okay. So 2 for t square into e power of minus a t u of t. Do for t cube into e power of minus a t u of t. And then you can write the answer in the generalized form, t power of n e power of minus a t u of t. So this is a task given to you today. We'll proceed for the next problem. Cos omega naught t into u of t. So how can I represent this? So I need Laplace transform for this. And also I need ROC for this. You also supposed to, you can represent this as e power of j omega naught t plus e power of minus j omega naught t by 2. Am I correct? Am I correct?
Yes, sir.
Yeah. Into u of t. This is how I can properly write. Next, tell me next. What should I do?
E power j omega naught t by 2 into u of t.
Right. Maybe you can write half like this. U of t plus half times e power of minus j omega naught t into u of t. Okay. Now, which property can I apply? Which property can I apply?
Linearity.
Linearity is obviously you need to apply because this is a sum of two functions that you need to apply. Then, for finding this product Laplace transform, what we need to do?
Scaling from
Which property? Can you please check shifting in S domain? Can you please check? Can you please check shifting in S domain property?
Yes, sir.
E power of S naught t into x of t. Laplace transform is, tell me,
X of S minus S naught.
right, x of s minus s naught. And what will be the ROC in this case?
If X
R
of t,
plus
Right, it is r plus,
R plus real part of S naught.
okay, clear now? Now, just compare the problem with this now. I'm rewriting this. You have half is a scaling factor, no problem. E power of j omega naught t, and in place of x of t, you have u of t. The other function is e power of minus j omega naught t into u of t. Okay. Now, in place of this s naught, what do we have here?
J omega naught.
J omega naught. That means earlier I told that s naught is a complex constant. And here in this case, s naught is a complex constant, but it is purely imaginary. There is no real part for this. Similarly, in this case, s naught is minus j omega naught. Now, can you, and also one more point, x of t is u of t. So, if u of t is our function x of t, what is its Laplace transform? It is 1 by s. Okay. And ROC is sigma greater than 0. Now, what is the result I have to write here? X of s minus s naught. What is x of s? 1 by s for u of t. So what should I write here now? 1 by s minus s naught. Am I right? Should I repeat? See here.
Okay.
Yeah, x of t is u of t. Okay. So x of t is u of t. Now what is x of s? It is 1 by s. Now here this e power of j omega naught t is multiplied with u of t. So what should be the answer? It should be x of s minus s naught. But x of s here is 1 by s. That's the reason 1 by s minus s naught. And what is s naught in this problem? J omega naught. So that's why I'm writing it as s minus j omega naught. Similarly, can you please tell me what should I write here in the second function?
1 by S plus J omega naught.
Right. S plus s naught, because you have a minus here. Or you can write s minus s naught also, no problem. I'll do that. You can use the same s minus s naught. So 1 by s minus, you'll have minus j omega naught. This is how you get s plus j omega naught. So here you have half e power of j omega naught u of t plus half e power of minus j omega naught u of t, written in the place of cos omega naught u of t. So therefore, Laplace transform of cos omega naught u of t means Laplace transform of half e power of j omega naught t into u of t plus Laplace transform of half e power of minus j omega naught t u of t. This is by the linearity property. Now, half times, what is the Laplace transform of e power of j omega naught t u of t? 1 by s minus j omega naught. Laplace transform of e power of minus j omega naught u of t is 1 by s plus j omega naught. So this will be, half is a constant and it is present in both the functions. So I'm taking in common. The Laplace transform of is 1 by s minus j omega naught plus 1 by s plus j omega naught. Please simplify this and tell me the answer.
1 by s square plus omega naught square.
Is it 1 by or s by? Check.
S by, sir, yeah.
Yeah, it is s by s square plus omega naught square is the Laplace transform of cos omega naught into u. Please remember this. I think you know this answer. This is a very known answer. And tell me now, what is the ROC? What is the ROC? Maybe I can give a clue. What is the ROC for this and what is the ROC for this? Maybe I can write it as R1, you can write it as, and then you have an intersection. Tell me what is R1. You are thinking because there is a j omega naught. Am I right?
Yes, sir.
Now just remember the point that it is only on the sigma it depends. Am I right?
Yes, sir.
So S now replaced with sigma plus j omega, and S minus j omega naught is written as sigma plus j omega minus j omega naught. Do you think any real part changed?
No, sir.
No, right?
No,
So
sir.
therefore, the first one, the ROC is sigma greater than 0, since it is right-sided. Here also this is right-sided. Here also it is sigma greater than 0. Therefore, what is R1 intersection R2 now?
Sigma greater than 0.
Sigma greater than 0. Nice. Now, next function, the problem. What is the name of this problem? Wait. Problem. Can you do this from your end because it is similar?
Yes, sir.
Okay. Please try this. Very similar to the previous problem. Also find the ROC. We'll proceed for the next problem. Next problem is a small extension for this. E power of minus 80 cos omega naught t u of t. Any guess how to do this? Don't see this as a big problem. Simply rearrange like this, cos omega naught t into e power of, because we know e power of minus 80 u of t very well. Rearrange like this now. Next, the problem is as usual, just like we did earlier. Earlier you have cos omega naught t into u of t. Now you have cos omega naught into e power of minus 80 u of t. So this can be written as e power of j omega naught t plus e power of minus j omega naught t by 2 multiplied with e power of minus 80 u of t. So this is written as half times e power of j omega naught t into e power of minus 80 u of t plus half times e power of minus j omega naught t into e power of minus 80 u of t. Earlier problem, using the same shifting in S domain, in place of x of t, you have u of t. Now in this problem, in place of x of t, you have e power of minus 80 u of t. So shifting in S domain property is being used. Again here, shifting in S domain. So writing the property e power of s naught t into x of t, Laplace transform will be x of s minus s naught with ROC r plus real part of this. Now, see the first quantity, see the first term, e power of j omega naught t into e power of minus at u of t. The second term, e power of minus j omega naught t into e power of minus at u of t. What is s naught in this case?
J omega naught.
Right. S naught in this case is minus j omega. Now, we know that e power of minus at u of t, which is now x of t form, will have the Laplace transform of 1 by s plus a, which is now x of s. So if x of s is 1 by s plus a, then tell me what is x minus s naught?
1 by s plus a minus j omega naught.
Right. I'll do one thing. I'll blindly replace that first. Okay. 1 by s plus a is x of s. In place of s, you need to replace with s minus s naught. So I'll be writing like this. And now this is, what is s naught here? J omega naught. So 1 by s minus j omega naught plus a. Similarly, this is 1 by s minus s naught plus a. But here s naught is minus j omega naught. So 1 by s minus of minus becomes plus j omega naught plus a. So properly writing this, Laplace transform of e power of minus at cos omega naught t into u of t is understood as half times or Laplace transform of e power of j omega naught t into e power of minus at u of t plus Laplace transform of half times e power of minus j omega naught t e power of minus at u of t. So half is a constant, so I can take it out. Now the first one, 1 by, I'll take this half as a constant first. Then 1 by s minus j omega naught plus a plus 1 by s plus j omega naught plus a. But here we have to properly arrange this in a form s plus a minus j omega naught plus 1 by s plus a plus j omega naught. Please simplify this and tell me the answer.
S plus a by s plus a whole square plus omega naught square.
Yes, s plus a by s plus a whole square plus omega naught square is the Laplace transform of e power of minus at cos omega naught t into u. What is the ROC?
Sigma greater than minus a.
Super. Because S naught is, what is S naught? S naught is a complex constant. So, and it is purely imaginary. It is not having, it is not affecting any change in sigma. Therefore, it ROC remains the same, that is sigma greater than minus c. Now, one more task for you. Please similarly do for sine omega. I'll give you the answer so that you can verify it. Omega naught by s plus a whole square plus omega naught square. ROC is sigma greater than minus a. So this also please solve at home in a similar fashion. Okay.
Yes, sir.